So they have a spectral type of D, and they have the mass of around 1.4. The maximum mass limit is 1.4 solar masses of these types
Aryan,
of stars.
Aryan, one second. Aryan, you have raised the hand. Please speak then. Aryan want to ask some question.
Hello, Aryan.
Yes,
In this, you say red dots are a small star.
yes.
They are cool, but stars can generate more than 1000 Celsius. Then why you say them cool?
So like these stars can have a temperature of about 1000 Kelvin, which is very low because our sun has a temperature of 5700 Kelvin. So according to star types, this is the one of the most coolest stars in the universe. Yes. Okay, so I will tell you a fun fact. So red is one of the coolest colors and blue is the hottest colors. And the sh- and there are many shades of it, as you can see in the picture given. Red is the coolest and blue is the hottest. So our sun falls in the middle of, it is somewhat yellowish. Yes. Are you satisfied with this answer?
Yes.
Okay. So, like these types of stars are found in abundance but very hard to observe because of their low luminosities. So, I think we have already found some red dwarfs that are near our solar system. So, I think that one was 1.4 light years away. I don't think so. There are many of them also, like Proxima Centauri, Ross 128. Yes. So there are many that are near to us. So they have a luminosity of half of the sun. So it is very, what you can call, low luminosities. So it is about 70 to 80% of stars in the whole universe, and they have a long lifespan of around 100 billion to 1 trillion years. So yes. So does anybody have more questions for me? Okay.
Yes, Aryan have a question. Yes, Aryan, you can talk with them.
Okay, Aryan, what's your question?
When a neutron star die, how many Celsius does it release?
So I think you meant by when a neutron star dies, it how much energy does it release? So the answer is about 10 raised to the power of 45 ergs. So this is 10 followed by 45 zeros. So yes, like if you write 10 and it the 10 has 45 zeros behind it, so it is more than the sun annual budgets. So yes, this would be okay. I will show you. I think I am not able to do that right now, but it is 10 raised to the power of 45 ergs or joules, you can say. So was that enough? Okay. So moving to the next one, it is about blue giants. So this topic, blue giants are massive stars that exhibit high temperatures and high luminosities. They burn their hydrogen fuel much faster than small stars, leading to a shorter lifespan. These stars are often found in star clusters and are key contributors to the chemical enrichment of the universe. So, like as you can see, blue giants are one of the most massive stars in the universe and exhibit high temperatures of about that they can reach 2 lakh Kelvin. So, like the most hottest stars in the universe has a temperature of 2 lakh Kelvin, that is about 50 times the surface temperature of the sun. So these stars are very massive and they use their fuel much faster than smaller stars, leading to short lifespans. So these giants can have a what you can call lifespan of about 10 million years. So these stars can, when these stars die, they what you can call release chemicals and they enrich, and then like the gold you wear and see are made in the heart of an what you can call neutron star. So are they are enriching the universe. So yes, does anybody have a question? Okay.
Yes, Aryan, please.
Yes, imagine a blue star and our sun collapse, then what happens?
If these two will collide, they will mostly give out what you can call chemicals to the universe, and they will what you can call destroy themselves. I will explain. The blue giant will release what oxygen, carbon dioxide, gold, etc., platinum. So this will be the end result. So if the so this would be the end result. So are you satisfied?
Yes, but I have one more.
Okay.
There is one project by NASA blasting nuclear bomb on Mars. Then they
Okay.
have a rover on Mars, so they destroy it or they continue their project.
So so your question is that they have a plan to nuke Mars, right? They will
Yes,
nuke. Okay. So what would happen? Like, so what if we nuke Mars? So it will mostly depend on what you can call the type of nuke that we are doing using. So I think it will make some global dust storms and temperature fluctuations. So you know that Mars is very cold and what you can call it will make the temperature like Earth. So there would be a lot of radiation there and what you can call some atmospheric loss would be also there and craters, a big crater will form. Yes. So
no, I am asking that they are planning to nuke Mars, but they have a rover on Mars that is only source they can get information. So what they can do, that I am asking.
okay, so uh, they are planning to nuke Mars. I didn't get your question, but can you explain the question to me?
Aryan, you can also speak in Hindi, not in Isu. can speak
Okay.
now.
So मुझे आपका क्वेश्चन समझ नहीं आया, आप वापस से एक्सप्लेन कर सकते हो?
कि जो मार्स है उसके ऊपर जो नासा न्यूक्लियर बॉम्ब गिराने वाला है, तो फिर उनके पास एक रोवर है जिससे वो इंफॉर्मेशन लेते हैं। अगर वो न्यूक करेंगे तो वो डिस्ट्रॉय हो जाएगा, तो फिर वो क्या करेंगे?
ओके, तो वो है एक क्या कहते हैं, दूसरा रोवर भेज सकते हैं, क्योंकि मार्स पे 6-7 हैं और 2-3 ऐसे डिस्ट्रॉय भी हो सकते हैं, जैसे क्यूरियोसिटी रोवर भी है। many so there are many rovers on Mars, so like 6 or 5, I don't know, but few of them will destroy. If they get destroyed, we will just launch few other rovers on Mars. So yes, we will just what you can call launch other rovers on Mars. That would be fine, right?
Can I add something here?
Then, till then, send a new rover to Mars when they recruit new rovers. Till then, what they can do to find out information about Mars?
1 second, Aryan. Aryan, 1 second. Nikhil bhaiya add some points. Yes, Nikhil bhaiya.
Yeah, I just want to add something here. Uh, they are not gonna destroy their rovers actually for NASA. Actually, they
Yes.
are planning to launch a nuke on the poles of the Mars, where there is a I mean, water is there in the form of ice.
Yes,
So
I
they want
think
to melt that water by nukes. So they are not launching directly on their rovers where the rovers were sent. The rovers will not get any impact by the
yes.
nukes.
So I think it will what you can call it can release the frozen CO2, thickening the atmosphere, right? It will release all the frozen stuff there.
Yes.
Yeah. Yes.
आर्यन समझ में आ गया आपको? असम
Yes.
आर्यन, आपको
Yes.
कोई क्वेश्चन हो तो आर्यन का नंबर है आपके पास, यू कैन कॉल डायरेक्टली ना, ठीक है?
Okay.
हाँ, और
Okay.
if anyone have a question, please raise an hand and speak without any hesitation. Aryan is only 11 years old. He is only explorer his knowledge about the presentation and all things. Many of our
Ye-
senior is also join here, so don't hesitate. Please guide to Aryan. Okay, okay, Aryan, continue.
So okay, moving to the next topic, which which is of supergiants. So these stars are among the largest stars in the universe, both in terms of size and brightness. So they can be classified into blue and red supergiants based on their temperature and color. Due to their mass, supergiants end their life in spectacular supernova explosions. So these supergiants are very what we call massive stars that have very short lifespan, and there are few types of it also. So they can be what we call their characteristics would be like they can be hundreds of times larger than a sun. They would have around 100,000 times mass of the sun, and I think so. Everybody here knows UI Scooty, right? It is a supermassive star, and it is about 1,708 times larger than a sun. So it is about only, it is very light. It is around 10 times massive than our sun. So yes. and has a surface temperature of about 6000 Fahrenheit, and it is 3,40,000 times greater luminosity than a sun. So yes, it is very light and very bright. So yes, these stars only have a lifespan of about few million years. Yes, and so does anybody have a question on this topic? I
Yes,
don't think so.
yes. Aryan have a question. Please, Aryan.
Okay.
Uh, you tell one time a black sometime star die, they become black hole, and there is some chance percentage chance that they can form a black hole.
You are telling that stars can turn into black hole, right?
No, I am asking what is percentage chance of a star convert into black hole.
Uh, I didn't get. I think so. You are telling. You are asking what is the chance of becoming a black hole of a star, right?
Yes.
So, so about 10 to 20% of the stars with mass below of 20 to 30 solar masses, they will become black holes. So, like lower mass stars, which are lower than 20 solar masses, rarely form black holes. It just depends on their mass. If they are larger than 20 solar masses, they would become a black hole. Yes. So it just depends on their mass.
Mm.
Okay.
Then what happen when a black hole die?
So like when a black hole has the very long, what we call lifetime. So I think what happens when a, so I think it will, what is it called, slowly evaporate, and this evaporating journey is very, what you can call, slow. But I think uh, there are many types of it, and based on their types, it will die. Like if it is small, it will take 10 raised to the power of 64 years to evaporate slowly. So like if I think you haven't heard of the, so like when a when there is a particle created near the edge of a black hole, there are two created in pairs. So sometimes what happens, they can escape, leading to what you can call mass losses. So it will take a long time. I'll tell you of the summary. So there is there are particles created near the edge of the black hole, and they are in pair. And sometimes it happens that they can escape. So that escaped mass is called evaporating of a black hole. Yes. So this was my answer. So was that enough? Aryan, is the answer satisfactory? Hello, Aryan.
Hello, yes.
Okay. So I think so. We were on a super giant. So These supergiants are one of the most massive stars in the universe, and I will give you an example of these also. Betelgeuse, it is an example of red supergiants. So there we were, okay. I think we were on types of supergiants. So there are many types of it, like the blue supergiants, O type, red supergiants, M type, yellow supergiants, F type, and
12 बजे.
क्या हो गया? Okay. So last type is of the luminous blue variable, which is of the LBV. So it is very unstable type. So moving to the next slide. So it is of the white dwarfs. So white dwarfs are remnant of medium-sized stars that have exhausted their nuclear fuel. They are incredibly dense with a mass comparable to the sun but a volume similar to the earth. So over billions of years white dwarfs cool away and fade off. So these stars, white dwarfs, are very small, medium-sized stars that have exhausted their fuel, and they have a size of the Earth, but their mass can be comparable to the Sun. So yes, they are very dense, and over billions of years, white dwarfs cool down, and fade away. So these are small, hot, and extremely dense stars. So these are just remnants of low mass stars around half of the sun to 8 solar masses. So they have exhausted their nuclear fuel, shedded outer layers. So our sun is also going to be a white dwarf sun in the future. So these are composed of degenerative matter like electrons and nuclei. Yes. So their properties would be like there was just 1 or 2% of sun's radius and have a mass of about 0.5 to 1.4 solar masses. So I think most of the people know what is the Chandrasekhar limit. So the Chandrasekhar limit is of about 1.44 solar masses. If this amount is exceeded by a white dwarf, it will become another stars, means frequent stars. Yes. And has a surface temperatures of about 18,000 to 3,60,000 Fahrenheit. So it is about it can be about 100 times the luminosity of the sun. It will lifespan of it is about 100 billion years to 10 trillion years. Yeah. So there are many types of it. One of them is hydrogen rich, helium rich, etc. So some notable white dwarfs are the Series A star, the Procron. I think most of the people know about the Series B, the nearest white dwarf here. Okay. So does anybody have a question of about it?
Aryan, speak. Yes, yes. Aryan has done.
Yes.
Yes.
Why stars are in different colors, purples, brown, black? Why they are in few colors?
I think your voice is not coming here properly. So I think you
I
meant
am
by
asking.
yes.
I am asking why stars are not in different color.
Okay,
They
I
can
think
also be purple, brown, others color.
Okay, I get your question now. Why can't the stars purple, right? Purple, green, etc. Okay. So I think stars can't appear this color because of the physics of light emission and absorption. So this there are some reasons. I think there is some noise coming. Okay. So why stars can't be purple? So because of the temperature. Stars surface temperature determines their color. Purple light corresponds to around 8,000 to 10,000. No stable, right now, no stable star has this temperature. And black body radiation. So stars emit light has black bodies. Purple light isn't a significant component of black body radiation. So there are many more reasons because of atmospheric scattering, etc. So like, and the next one is about why stars can't be green. So emission peak. So like this peak at specific should be at hydrogen 656.3 nm, and green light is about 5 to 20 nm. So this isn't prominent emission peak. So there are absorption lines also. So the star spectra shows absorption lines which removes specific wavelengths including green. Okay, but I will suggest you that you read about the black body radiation. So the black body radiation is what you can call, if you light a candle, you will see that in its center it is blue, and at the top it is what you can call yellowish. So that happens because blue is one of the hottest colors and yellow is what you call middle one. Okay, so is this answer enough? Aryan, is this answer enough?
Yes.
Okay. Moving to the next topic, it is about neutron stars. So neutron stars are the remnants of massive stars that have undergone a supernova explosion. They are incredibly dense with a mass greater than the sun, compressed into a sphere of about 20 kilometers wide. So neutron stars can't emit beams of radiation, making them detectable as pulsars. So these things have a mass greater than the sun and are compressed into the size of about 20 kilometers, around the size of Paris. Okay, so these stars can emit beams of radiation, making them detectable as pulsars. So these stars are very dense stars, you know that, and they are made up of pure neutrons. So I will also tell you how they are purely made up of neutrons. So these things are extremely dense objects formed from massive star collapse, and they are composed mainly of neutrons with a small amount of protons and electrons. So they have a radius of about 20 kilometers and mass of about 1.4 to 3 solar masses. Rotation periods of about milliseconds to seconds. So it can, the fastest, I think the neutron star can rotate 600 times in a second. So yeah, so they have a what you know, very strong gravitational force also.
Yes, Aryan, please speak. They, yes. raised in hand. Okay, please.
Okay, so
Yes,
I think this
Aryan
is
Assam, Aryan Assam, please speak. You are mute now.
yes. What happened when a galaxy collapses with another galaxy?
Okay, I think what what if a galaxy collapse collapse
With
with another?
another galaxy.
So I think this is I think happening right now. Our Andromeda galaxy and Milky Way galaxy. So these galaxy collision types, there will be some types also of it, like the minor merges, small galaxy merges with a larger one. Major major merge, two similar sized galaxy collide. So yes, it can what can call boost star formation. Collisions trigger starbursts, gas and dust redistribution, fueling stars formation and black hole growth. So it would be beneficial for the galaxy that is merged. Yes, because it will boost the the star formation, gas and dust, fueling stars, black holes, etc. Yes, it will just what you call be helpful for the galaxy. And I think it is happening right now and it is happening right now with Andromeda galaxy and Milky Way galaxy. So yeah, so this was this enough for you?
Yes.
So there was a common doubt in people why there are no proton stars. So to explain this, we have to know why neutron stars exist. So they are very dense. So they are electron degenerative. So like the pressure, the core collapse. So massive stars core collapse causing density increase and that pressure only neutrons can handle. So this thing only neutron stars can handle. Okay, so was that enough? Okay, now I think moving to the next one, black holes. So look, okay. So the next topic is about black holes. So black holes form when massive stars collapse under their own gravity after a supernova. They have gravitational fields so strong that nothing, not even light, can escape from them. The event horizon defines the boundary around a black hole beyond which nothing can return.
Aryan,
So, yes,
more people raise in hand. One of the Chandra Mohanji and Aryan also. Chandra Mohanji, please.
What is the size of black hole right now? If anyone know.
okay, your question is
What is the size
sizes of.
black holes right now?
So, there are many types of it also, like stellar black holes, intermediate black holes, and supermassive black holes. So, these stellar mass black holes are about 1 solar mass to 20 solar masses. Like the stellar black hole can be weighting around 20 solar masses or the 20 suns, and intermediate of around 100 to 1 lakh. These can reach a limit of 1 lakh suns And the last one, supermassive black holes, can reach about 1 billion to 10 billion solar masses. So yes, there are many largest known black holes like 10618, which NG621275. So 10618 is 6.6 billion solar masses. So yeah, and there is one more, Helmberg 15A, which is 40 billion solar masses. So okay, those so stellar black holes are about 20 to 30 kilometers in diameter, and supermassive are about 1 million to 10 million kilometers in diameter. So yeah, so I think this so I think 10618 size is about 6.6 solar billion solar masses and is about 1300 AU. The distance between its diameter is about 1300 AU, or 1300 times the distance between the sun and the earth. So okay, so does anybody have a question else?
Aryan Assam have a question. Yes,
Okay.
Aryan, please.
Yes, imagine a neutron star came in front of the black hole. The neutron star is bigger than 2 times in front of black hole. Then what happened? Imagine.
Okay. So I think so. The black hole, what will happen? They will merge, and the black hole will start eating the neutron stars. So, like what you can call, the neutron star will be devoured, or the black hole will eat it. Just eat it, and there will be nothing left of the neutron star. So, like nothing would happen. Just the neutron star would get eaten by the black hole. So, okay, was that enough?
Yes.
So, in the picture, as you can see, the black hole has a ring around it. So, I think it was called the discretion ring. So, yes, and this can reach a temperature of about millions of thousands of degrees. So, I think move to the next. It is about brown dwarfs. So, brown dwarfs are stellar objects that are too massive to be considered planets but too small to sustain hydrogen fusion like stars. They occupy a gray or area in the stellar classification, often referred to as failed stars. Brown dwarfs emit infrared radiation that are difficult to detect with traditional telescopes. So, as you can see, these are things that are massive, massiver than Jupiter, and then they are about 80 times the mass of Jupiter and often referred as failed stars. So yeah, these are not considered stars and not considered even planets. So these are very extremely hard to detect with the infrared because they emit infrared radiation, so are difficult to detect with traditional telescopes. So the next topic is about black dwarfs. So they are made
Aryan,
in the
one
end of.
second. Aryan, 1 second, better. Aryan have a question. Yes, Aryan. Actually, he's raised a hand many times, and also you can see your message also.
Yes, Aryan, Jupiter is made it with full of gas. Then on Jupiter there is one big storm. Then how that storm is present on Jupiter? Because Jupiter is made of gases,
Yes.
storm gets no surface. Then how it is possible?
So as you can, so in the case of it, you will see that Jupiter, what you can call, Jupiter is very massive and has no surface, and even in that type, storms can occur because Jupiter is just made up of storms, and they just hover in space, where what you can call, it just hovers around. It hovers around above. So like, uh, so was that enough? Was that enough?
Yes.
Okay. Aryan need the security. So I think some new people have also joined. So thanks for joining. So if does anybody have a question, so they can tell me by raising their hand. Okay, so our topic was the black dwarf. So they are made in the end of a white dwarf and are theoretically right now cause white dwarfs have a very long lifespan of around 10 trillion years. They are not possible right now. So they can have a lifespan of around 10 raised to the power of 3200 years. So they will be very cold around 5 degree Kelvin. So like these things will take a long time to form of around 10 trillion years cause white dwarfs have a very pretty long lifetime and they can have a temperature of about 5 degree Kelvin. So around absolute zero and
Yes,
have a life.
Aryan, yes, speak Aryan. You have raised the hand. Aryan Assam. I don't know. Actually, he just raised. Aryan, you can continue.
Okay. So they can have a lifespan of around 10 raised to around 3200 years. So that is a pretty long lifespan. So moving to the next slide, red supergiants. So these are the largest stars in terms of volume and are at the end of their nuclear burning phase. They are cooler than blue supergiants and often exhibit a reddish hue. Betelgeuse in the Orion constellation is a well-known example of a red supergiant. So these are made in the end of the nuclear burning stage. So our sun would also become like Betelgeuse, which is a well-known example of a red supergiant. So red supergiants are the largest stars in terms of volume. So these are the largest stars in area and are at the end of the nuclear burning phase. So okay, this was it. I think we have already discussed these topics in what you call the beginning of the stellar classifications. So carbon stars are a type of red giants that have an abundance of carbon dioxide in its atmosphere. They are categorized by the distinctive spectral features and reddish color. The presence of carbon can indicate advanced stages of stellar evolution. So these are just a type of red giant stars that have too much carbon inside of them and are characterized by their distinctive spectral features and reddish color. So the presence of carbon can indicate advanced stages of stellar evolution. So okay, moving to the next one is about Wolf-Rayet stars. So these are massive stars in an advanced stage of evolution. that have lost their outer hydrogen layers. So they are known for the strong stellar winds and have high temperatures. These stars are often precursors to supernova events. So these are just types of massive stars in an advanced stage of evolution that have lost their outer hydrogen layers. So as you can see in the picture, this was just a Wolf-Rayet star in its advanced stage of evolution by losing all of its hydrogen layers. This is also called a nebula, and our sun will also uh, experience this type of thing. And the next one is about T-Tauri stars. The T-Tauri stars are young stars still in the process of formation, often surrounded by a protoplanetary disk. They exhibit variability in brightness and strong stellar winds. So these T-Tauri stars are important for understanding the early stage of stellar evolution. So these stars are formed in the beginning of the stellar evolution. So these are just young stars going to become pre-main sequence stars and main sequence stars.
Aryan,
So okay, yes.
Aryan Assam have a question. Yes.
Hello, Aryan.
Yes.
I have question.
Okay.
Why red giants cannot become two black dwarfs?
Can you repeat?
Why other color drafts cannot change into black draft?
Okay. Okay. I think there is coming around. So please mute your mute. Okay. So you know that every star is going to become a black dwarf. Even every supergiant is going to become one. Cause after even if the supergiants become black holes, after some times, after a Google years, they will become black dwarfs. So yes, every star is going to become a black dwarf in the end. Yes. So this was the answer. So moving to the our topic. So these Taurus stars are young stars. So they will become first. They will become. I think some new member has also joined. So thanks for joining. And if you have any question, you can raise the hand. So okay, these Titori stars will become pre-main sequence stars and main sequence stars. And as you can see, the ring around them is powering them, and they are also called pro-planetary disk. The dust, as you can see, can become planets like Jupiter, Earth, etc. The Cepheid variable. So these are a type of stars, pulsating stars known for their regular changes in brightness. Their luminosity is closely related to their pulsation period, allowing them to be used as a distance indicator. They play a role in measuring astronomical distances in the universe. So as you can see, these are just a type of stars that are known for changes in the brightness, and their brightness is related to their pulsating period, allowing them to be used as distance indicator. So Myra's variable are another type of pulsating stars, especially red giants that exhibit significantly brightness variation. They can brighten and fade over a period of about 80 to 100 days. These stars are provide insights into the late stages of stellar evolution. So these are just another type of pulsating stars. especially red giants that exhibit bright variation. They can, what can call, be bright one day and just fade over a period of about 80 to 100 days. So yeah. So now we are going to the next topic, AGB stars. So asymptotic giant branch. So these are the late stage stars that have exhausted hydrogen in the core and are undergoing helium burning. They are characterized by mass loss and the formation of planetary nebula. AGB stars play a crucial role in enriching the solar interstellar with heavy materials. So our, what we can call, sun is going to be in this position one day. When it runs out of hydrogen, it will go helium burning. So these types of stars are called AGB stars. Okay, move to the next. So does anybody have a question? Change about. Okay, I don't think so. Does any? Okay. So
पीएल सर पीएल सर कोई क्वेश्चन है सर सर लग रहा है नीचे यस आर्यन यू कैन कंटिन्यू
okay. So flaring stars such as flare star exhibit sudden increase in brightness due to magnetic activities. These These stars are often cool, late type stars like red dwarf stars. Flares can have significant effect on surrounding planets, including their atmosphere. So these stars are flare stars that exhibit sudden increase in brightness due to magnetic activities in their core. So these are just cool types. So late type stars are like red dwarf stars. They appear green because of atmospheric refractions. Okay, moving to the next one. So ultra luminous X-ray sources ULX. So these are extraordinary sources of X-ray emissions that exceed the luminosity of typical X-ray binaries. So these may be linked to black holes or neutron stars interacting with companion stars. The nature of ULX is still a subject of active research in astrophysics. So these are very rare and only 400 plus candidates have been chosen, and the biggest extra nuclear X-ray sources is about 10 raised to the power of 39 ergs. So yeah, these were this and stellar classification systems. So these are still using the modern Canon MK system, which includes spectral types O, B, A, F, G, K, and N. Each type corresponds to a range of temperature, colors, and sizes. This system helps astronomers communicate effectively about various star characteristics. So as you can see, this is just the first slide, but in a more formal way. Yes. Okay, now moving to the questions one. So, can anybody answer the first question? What are main sequence stars? I don't think so. So, main sequence stars are the most common types of stars. They have solar masses of around 1 or 2. So, red dwarf and white dwarfs are types of stars that fall under the category of, they are mostly the category of D, which is very low and have pretty long lifespan. What are blue giants? So blue giants are massive stars that are pretty, what you can call, bright, because most of the giant stars are bright because they exhaust their fuel faster than smaller. So supergiants are type of stars that are very massive and would exhaust their fuel in 10 million years. So neutron stars are stars that are composed of neutrons and pretty dense, and they have a gravitational field of about 100 billion times of the Earth, and they can be around one. They can be massive of around 20 solar masses and be composed in a what can call a space of 20 kilometers. So black holes are very compact objects, and they have a horizon where nothing, not even light, can escape, and they have pretty strong gravitational field. They can be of billions of solar masses and composed in just 1 or 2 million kilometers. So black dwarfs are dwarf stars that appear in the end of everything and have a lifespan of 10 raised to the power of 3200 years. So yeah, thanks for joining us today. Okay, so does anybody have a question for me? Nikhil sir, Nikhil bhaiya, are you here?
No, Aryan. As for I don't have any question.
Okay, you don't. So did you enjoy that? Was the presentation good?
Yeah.
Okay.
जी TL sir and Sanjay sir is also joined. So Sanjay ji, actually you have joined first time. Aryan, on your video and can talk with the sir also. सर आपका अनम्यूट है सर, आप अनम्यूट कर लीजिए सर, म्यूट है। आर्यन ऑन योर वीडियो बेटा।
Okay.
And one person is Sanjay ji is also joined, so try to speak with them.
Okay. So, can is my camera on right now?
No,
Uh,
yes.
Okay. Now, so does anybody have a question for me? I think not. So, hello Sanjay sir. I think you have joined for the first time. Hello Sanjay sir. Are you here? I think he's joining for the he's I think he's joining for the first time. So it is around 12.
So
So
Nikhil ji, you have suggestions? Any suggestion for Aryan for improving his knowledge and PPT all things?
Yeah. Actually, today PPT I find it is better than last.
Okay, sir. Thank you.
Yeah, he's improving.
Actually, he has a tablet, but he is lacking too much. Actually, after 4 to 5 days, he has got the laptop. Then he is present well with PPT also.
Okay.
okay.
जी.
Oh, so 12. So I think it is 12:10 here. We should maybe end the meeting here. So I hope that everybody liked it, and I think I will make the next presentation about general relativity, etc. Yes.
Okay, Aryan.
Yeah,
So you have in Sunday, na? The next PPT will Sunday.
Sunday.
Okay. So also timing is also changed. Na 11 o'clock is best. And Nikhil said actually one pop-up is also going on in blue space and 7 o'clock meeting. Uh, what is the
Right.
time?
Uh,
न- आपने ही सर वो डाला हुआ है मीटिंग का 7 5 to 7 वर्चुअल.
no, no, no. That was on last Sunday. It was done actually.
अच्छा.
Our anniversary meeting.
Yes, yes.
Okay.
No, no, it's done. I think we can remove that from the pinned comments.
Yes. So okay, thank you so much, Aryan. You have joined and you have presentation. Your present and all things. I have a suggestion for you. You can improve more and more also, like the
Yeah.
presentation, your speakings, and your knowledge also about the anything you have briefed. Then you have to know about the all things. Like you have start. So you know very well about the stars also, how to forming and how to all things. Okay.
One more thing I want to add. Uh,
Yes.
we have given a link for our anniversary quiz trivia challenge. So if Aryan is interested, he can able to participate.
Yes, Aryan, you have completed or no? You have. I have seen na anniversary participates is going on from the next year. You have done na. Try
No,
to.
I don't think so. I don't think so. I had done that.
So today you have to complete na without any pay. And previously also you have got the good marks also. Nikhil bhaiya say actually, but not an age limit, so that's why you have not selected over there.
Yes.
Okay.
No issues. Just try to attempt it because today is the last date for that quiz. So
Okay, cosmic buzz, right?
yeah.
Thank you so much to join everyone, and Sanjay sir and TL sir and Ramesh ji also joined today. So thank you so much for joining us, and once again we will also join in the Sunday also and 11 o'clock. Okay, Aryan, bye.
Okay.
Thank you.